Good morning. You're welcome to today's lecture on the course BDT 253. Pharmaceutical calculations. Though we are still on the topic what? Approximations, right? So today we will go over to what? Estimation, right? So what do you understand by the term estimation? To estimate, what does it mean? Who can help us? What does it mean to estimate? Huh? To estimate, what does it mean? You want to make an estimate. What does it mean to estimate? Okay, help us. Yes, help us. Good morning. Help us. Guessing. Is it really guessing? Oh yeah. Ijomoya. Tell us.
All right. You don't say you want to estimate the value.
Okay, estimate is just like estimating it, right? You said that to estimate is like estimating what you want to do. Any other idea? Good, you go far. It's not the actual, it's not the exact, but at least you should be able to an idea of what the thing is or will be, or maybe it's not really guess. Guess is just like just saying things that comes to your mind. But this one is that you have a particular something around the exact value. It may not be the actual value. Okay, so that's what an estimation. Maybe if you want to, let's assume you want to, it's a kind of, call it projection. Maybe you want to do something. Okay, we want to. What are you dancing to? Okay, so maybe you want to, let's assume you're preparing for your wedding. And in the current situation of the economic situation, maybe your friend did hers or did his last week Saturday, or let's say last month. And that's okay. He spent around, let me see what you put. Maybe he spent around 2.5 million. Then maybe you will be like, let me see your breakdown. Okay, the suits, the wedding gown cost something like this in the past. Maybe say 50K or 60K. It's okay. Maybe let me estimate or budget around 70K, considering the economic world situation. You may go there, it may be less than 70K, it may be above 70K, something like that. Am I communicating?
Yeah.
Now, bringing into what we are doing, if you want to estimate, the reason why we estimate, sometimes you may be doing you may have something to calculate. By me looking at it, you can say, okay, the result will be like this. The result we have this number of this place value. It will be in a level of this particular place value. Let's assume now you have a problem or something to calculate, and from by me looking at it, you may estimate that the answer will give you something like let's assume something in the neighborhood of 2,500. Just by me looking at the, you have been getting answer around 234. Something will strike your mind. Something is wrong because the figures I saw before doing calculation give me something that will give me something has value that will give me something around 250, 2005 if I do this calculation. But why am I getting? Sometimes I may come here, I may be solving questions on the board. I don't know if you have noticed it. I may be solving a question on the board. At the point I will stop. You'll be like, what's going on? I'll be like, I'm not getting there ahead. I am. So what I'm doing may not get me to the value I have estimated already, even without solving it. That's how you learn how to play with numbers. That once you seek a question, you already know where the answer will get to. That's estimation, and it will help you to have what is called check. I call it check. Doing your calculation check. It will guide you if you are going astray in terms of taking a path that will lead you to a wrong result. You will know. But as you are solving, you won't even know whether you are getting it right or not. You solve it at the end, you get the wrong answer, and you won't even know that you get the wrong answer. That's how you will work with numbers. That even if you've not seen the answer before, maybe a question you've not seen the answer before, you solve it. If you get the answer correctly, you will know. If you get the wrong answer, you will know. Even in the process of getting to that answer, you will know that you are taking the wrong path. Am I communicating? So this is what estimation is all about, and we employ place value so much. We also employ this rounding too. Remember, I told you that rounding is the substance of what? Approximation. It is a technique. You cannot talk of approximation without rounding. So just as we saw rounding in significant figures, we saw rounding in decimal places, we also saw rounding in approximation that has to do with place values. This one again in estimation, we also need what? Rounding. Because there's in estimation there's two values. There's the one we call actual value and the one we call estimate. Am I communicating? So if I give you a question that has to do with estimation, and you go and punch your calculator, and give me actual value, you have failed it. You don't estimate anything. There are some that will go and start doing normal calculation. When you did not estimate it, you calculated calculation and the estimation. You just calculated it and gave me the actual value. That is not estimation. But estimation does not have a particular answer. Am I communicating? A particular answer. The answer you get may not be exactly the same answer. But by me looking at it, I will know whether you actually estimated or whether you just guessed. Okay, you point a calculator. The answer is 2,494. You now say, okay, let me give him 2004. You may do that even in OBJ self. You rarely see, except if I want to give you a question that has to do with estimation in OBJ, there will be an instruction on a particular thing I expect you to have. But in as a theory, you have to show me how you got that year 2004, or whether you just close your eyes and open your eyes, and because 2004 is equal to 2,495, you now write 2004. So please, this is a kind of introduction to what estimation is. So let's now look at what we have here. So it is important for pharmacy students and pharmacists. This is what you have in your material. It's important for pharmacy students and pharmacists to recognize resemblance of the result of a calculation. Am I communicating? You should be able to do that. You should be able to do what? Do that. And by performing an estimation of the answer before the calculation, you can get an approximate result. Predetermined. You can predetermine the approximate what? Result. So this helps you to actually know the correct dimension of your what? Answer. You're able to know the correct dimension. If you are going the wrong way, you will know. If you are going the right way, you will know. So you're able to know what? The correct dimension of your what? Answer. Even the right placement of the what? Of the decimal what? Point. Maybe you are dealing with fraction. You are dealing with decimal fractions. It will help you. Okay, now let's assume you have some calculation that has to do with some calculation has to do with 25.47. Look up times 26.10. Look at this now. Look at this. You see this is multiplication. It's doubling. You are multiplying this and this. Now, but if I want to do this calculation, once I look at this, I will know that my answer to the right of the decimal point, I must have up to 4 figures, 4 digits. I don't do told. I should have up to 40 digits to the right of my, to the left of my decimal point. I should have up to 4 digits. Then after punching my calculator, I end up with 2 digits, maybe 20, maybe 79.2. Something will tell me that something is not so well. I'm not complicated. Punch it. How many digits to the left? Is it 3? 25 points. This time, this is what? 3. Is it 3? Okay. Here to the left, we got 3. Okay. Let's see now. Let's see. This is 25.47, right? If you move it, this is 25.417 times what? 3 is 4 what?
47. That's 2547.
Times 3 is 4 what? 2. Here is what?
2610.
Times 3 is 4 what? 2. Okay. This and this alone will give us times 3 is 4 what? 4. This one, multiply this and this. What's the answer? Just do this and this first, separately. Forget the decimal point. 6 is 4, huh?
7670.
Is that all?
No, 6.
Where is your? I'm coming. What? 6 is what?
664.
76. Is that all?
Yes.
Times 3 is 4 what? 4. So if we are to bring this thing back here, what will give us? 2, right?
Yes.
1, 2, 3, 4. Okay, this 0 here. This 0 here has effect. It's okay, no problem. It's what? 3, right? To 3. All right, change this into something else. Let's see what will give us. Maybe like 4. Punch it. Let's see what it will give us. Is it the 3? How many digits?
66578.
No, just number of digits.
It's still 7
Because it's 3 years.
Okay, 3 or 4 here. But you got the point I'm trying to make, right? 3 here, 4 here. Okay. But you got the point I'm trying to make. Maybe out of error, you punch your calculator and you end up having a result that will give you 20 something, 7, maybe 66 point something. You know that something is wrong. Come in. You know that something is what? Wrong. Now, so that's basically, so let us now go to operations in this estimation to see how it goes. Okay? So we look at addition mainly, even subtraction. Addition and subtraction follow the same what pattern. But let's just work on addition because of time. You also look on what multiplication and division. Let's see what we get out of it. Okay, we have something like this. Okay, let's you use the examples here. We have to add 7428 3652 1327 4605 2791 4605 2791 and 4490. Look at this how many? One, two, three, four, five, six numbers, and all of them are in the same they have the same place values. Three of us, they have the same what place value, all of them. So here there are different ways to that. All you know is that you have to calculate. Just may look at it, you estimate neighborhood of what the place value the answer will be, and possibly, yeah, mainly the place value the answer will be. Now, if you watch now, you can decide to round this thing off. You can now that is in thousands, okay? You can decide to round it off to the nearest thousand. Just make that and add and get your answer. Am I communicating? So depending on the type of value you may start to round it up to the nearest 100 out together and add up and get your answer. So here all of them are in the same place value. I can just round to the nearest what and go my way. Here is what? 7,000. Here is what? 4,000. Here is what? God bless you. 1,000. Here is what? Here is what? Here is what? Here is what? Is it 4,000?
4,000, yes.
Are you sure?
Yes.
Are you very sure?
Yes.
I can just do 7 plus 7. Listen carefully. They have three, right? I put that 3 by the side. 7 plus 4, 11, 12, 17, 24. I added 3, 24,000 and go my way. Straight. That is sometimes if you have a question on the board. So some of you will be carrying your calculator. I'll just look at it. I'll just look at it and tell you the answer. It's not magic. It's estimation. And sometimes you may even estimate and get the exact what value. Yes, sometimes there's some. It depends on the nature of the what numbers. There's some numbers there's some operation you will estimate. Your estimate will be the same thing with the what actual what value. There are different ways you can go around it, but the most important thing is that be careful about where you are rounding off to. Had it been we have some numbers here that is in hundreds, and I may be forced to round to the nearest what 100. Are we together? And I may be forced to round to the nearest what 100, because I cannot just throw it away like that. Am I communicating? I may be forced to round to the. Then what is the actual value of this number? Add up. 24,000. Now let me shock you more. You may decide to run to the nearest 100. You're not wrong, go. Mark my words. You're not what? Wrong. You may decide to run to the nearest 100. Let's do it. This is what? 7 what? 7,400, right? 2 of us. This is nearest 100. That's 2 of us. This is what? This is what? This is what? I may add up this place and get an answer. What's the answer? To give around 24,000 something, 3 or so. 24.3. See the actual value. 24,293. See the estimate. It's still not wrong. Estimate must not be lower than the. But what matters is, let's assume you say you want to estimate. I'm getting 6,000. Oh boy, how far? Something is wrong. Two of us. You're estimating something. You're getting You're estimating and you're getting. Okay, this is 24. Okay, you're getting 30,000, 40,000. What are you doing? Something is wrong somewhere. Two of us. But this is correct. This is also acceptable. That's why I don't set this question as OBJ if I want to set it. Because some people just close their eyes, and unless I want to dash you mark, bonus, some people will still fail it. Unless I want to give bonus, some just close their eyes, punch the actual value. You give them 2,000. I say, okay. They will look for the option that is closer to that one and take it and disappear. But some will still end up doing what? Failing it. I've seen things, and things have seen me. All right, let's look at this example here from these practice problems. Let's solve one from this practice problem, then move to another example. Move to multiplication. Where do I always look for? Can I clean here? Now look at this. Look at this. The question says that we should add 5,641, 2,177, 294, 8,266, 3,503. Look up. This are in what? This one is in what?
100.
So let's round this one. Let's round to the nearest 1,000. And round to the nearest what? Then get the actual value and compare. The same way we did here, okay? So let's round to the nearest 100. This one is what? 5 what? Nearest 100 first. This one is what? 2,800. This one is what? 300, right? This one is what? 8,300. This one is what? If you add up that, what's the answer? 19 what? 19,900. Calculate the actual value. 19,881. Then round to the nearest 1,000. Let's see. Let's round to the nearest 1,000. Can I clean here? So nearest one, this one is what? 6,000, right?
Yes.
This is what?
2,000.
This is what? 0. Good, thank you. It's nothing now. It's not up to right.
Yes, sir. 8,000.
This one is what?
4,000.
Huh?
4,000.
What's the answer?
20,000.
20 what? Both are what? This is correct. This is what? Correct. This is a good estimation of this, right? This is also a good estimation of what? This. It's easy, right?
Yes.
So by me looking at this thing now, you already know exactly where. Maybe after punching a calculator, so some of you your calculator, if you punch something, it will give you another. If you punch an operation, that's why you don't need to depend on that thing. if he deals with you, eh? My God. Don't so depend on it. Don't do that. Honor give an exam. Heat, heat. Is it about ever? Honor give an exam. So you don't need to solely depend on. You need it, yes, to be fast. If you are allowed to use it, but do not. Maybe you're in an exam hall. You are punching. The thing refuse to work. Your neighbor is telling you, leave me alone. I'm busy. Okay, I'm not. Hey, you hear 10 minutes to go. You are stuck. You don't know what to do. You start drawing oranges. They taught you in nursery school. You start drawing oranges. You start trying to remember it. 5 minutes to go. You know me now. Once is palm I collect, you leave the hall. So please, as you are learning, please practice some things without solving, without using your what calculator. It's very important. Practice it. It's not everything that you just carry a calculator and start solving. Not everything. Okay, let's do addition that has to do with decimal, that have decimal point. I think after that now we will move over to the next operation if there's still time. Okay, let's look at this one from this practice problem in the okay, the question says we should add this amount of money, $75.82 US. US dollars 37.92. $14.69. $45.98. $28.91. $49.87. Remember, these numbers are not abstract now. They are what? Please, after this meeting, please retain this what? USD, please. I'm begging you now. Retain it. Hey, don't give me an abstract figure, abstract number as an answer. You fail it. There's no, it's not negotiable. Okay, so let's look at this number. This, if you watch, all of them are in what place value? 2 place value. What are you saying? You are talking about decimal places. Please don't confuse decimal place and place value. Please, they are in what place values? All of them. They are in 100 what? 100th, right? 100th. Good. So, because they are in hundreds, you can decide to round. If you want, you can round to tenths. Okay, if you want, you can round to what? Tenths and add up. Are we together?
Yes, sir.
You can round to tenths. You know, these things are denominates. They are what? Denominate, and they represent each of these represent an amount. So just be careful the way you do what handle them. It's not ordinary It's not, what is it called? It's not abstract numbers. You can just do anything you like with it. Am I communicating? So if I have to solve this, I can run to the nearest tenth and add up. So if you run this to the nearest tenth, what will you get? Point what? A0, right? Here is what? Past 7.90. Here is what? Here is what? Here is what? Here is what? Which one is that? Thank you. No, it is right. To nearest tenth is right. It's 49 point what? But are you aware that we are just putting this zero just for calculation's sake? Hello? I'm just putting this zero. Are you aware that this also 100? Hope you know. As per the radius, but I'm just putting it just to show that I will not throw it away like that. For the purpose of the what? Calculation, okay? Yeah. So here is what? 0.90, right? Sorry, 0.80. Thank you. If you watch now, everything here is what? Okay, here is what? God bless you. What else? Run the nearest tenth, oh yeah. Which one? What else? Are you now? So we should continue. So if you watch now, here is what? Here is what? It's, please, someone should get the actual value, please. Here is what? 17, right? 17, 20 what? 24, 20 what? 17, 24, 33, 42, right? Oh yeah. They are keeping quiet. Oh yeah, calculator babes and guys. Yes, what? 25 what? Point what? 19. Point 19, please, not 19. This is not 19, it's 19. Okay, here is what? This one is correct, right? So 4 comes here, right? 9, 16, 20, 26, 34. For 3. 11, 14, 15, 19, 21, 25. Now let's round to the nearest 100. Let's see what the answer will look like. So God bless you. Nearest 10. Nearest what? 10. Let's see what the answer will look like. Here becomes what? 7 to what? 76 point what? Remember what we are putting this thing? It's 76 now. 10, not 10. I said 10.
Unit 100. This one is 100.
Okay, she has a question. She says she thought it's units 10. So should it be to the nearest unit or nearest 10?
Nearest unit for this thing.
Huh? Okay.
Sir, he's correct.
She's correct, right? So shoot to the nearest Smith. Thank you. Nearest what? Unit. Alright, so here is what? Here is what? That what? That what? Okay, you see. That what? Please, this level is just to balance places. So in real sense, it should what? 76. Hope you know. In real sense, it should what? 76. And I just put it here to balance because we are not punching calculator. That's why I added point what? 0 0.
Sir, but in exam, is it a month
I don't understand that.
like the exam?
I've already told you why I put it. So if you put it, I want it for you. I'm going to explain something that is not. You know that this thing is not. If it's like this, it's what? It's 100. So you know. But I told you because I want to align. But it's okay for the purpose of this because we are not. It's okay. It's not bad. I think it's not bad to remove it. Please, let's not because I may not be the one that will mark it. Tomorrow you may see yourself somewhere else. Okay. This is nearest what? Nearest what? Thanks. Good. And this is nearest what? Unit, right? Good. But you know that we're at the end. If you calculate at end, no one. Here is what? US what? US what? Here is what? 15. Here is what? Here is what? 46. Here is what?
29.
Here is what?